Question 4 was all about transformation geometry. So in part A, you're given a square and you have to draw in all of the axes of symmetry. So you have some diagonal ones that go like this. And you also have a vertical one, goes like that, and a horizontal one as well. And that's it. If you, say, fold the square over any one of those lines, it will kind of fold exactly on top of itself. Or if you, for example, put a mirror on one of those lines and looked into it, you would essentially see a square. Part B gives us a shape F and shows a few different transformations that have been done to it, and we have to figure out which one is which. And we're given the answers as well. We're told that there's a translation. That is when you essentially just move a shape, that's all it is. There's axial symmetry, very similar to part A. It's when you transform something. It's essentially like you put a mirror down and you look at what the mirror image looks like. And lastly, central symmetry. That is when you do symmetry through a point. The result is essentially that it gets rotated, so that's an easy way to detect it. So what do we have in each case? Well, in part A, it looks to me like it's been rotated. If you put a mirror down, say, then it's not going to be reflected exactly. If you try and move the F, it's not going to be sort of upside down and flip left to right as it is. So the only one that can be is central symmetry. Part B gives us essentially the image has been flipped over. So that's an axial symmetry. Part C, the image looks exactly the same as the F, it's just been moved a bit, and we call that a translation. And in part D, it's a little bit harder to tell, but if you take a look at a line going like this, hopefully you'll be able to see that it's been mirrored over this line, and we call that axial symmetry.